Hey, good morning, everybody. This is Mr. Ainsworth. We're going to go over the mathematics of combinations here, dealing with some of the mathematics in section 2 here in chapter 9. And we'll apply this obviously in the workbook when I get back. But here we go. So we're going to go over through the mathematics of combinations. So I need to define some variables first. So let's go off to the side and let's define a few things. So couple definitions first. I'm going to let n refer to the size of the population. You'll see what this means in a second here. So the size, come on, the size of the population. We're going to let r represent the sample size, okay? So which will make sense here when I get into an actual problem. So n is the population size, r is the sample size, and then we have this new terminology, which you may have seen this in Algebra 2. Some teachers teach it. It's the formula for a combination here, which we're going to apply here in multiple different problems. And it goes like this. So n choose r, okay? So we use C for choose or combinations. We say choose though. So n choose r, that's how you say it, is equal to the following formula. So n factorial divided by r factorial times n minus r factorial. Okay? And so what I need to do is define what it means to be a factorial, and then we can apply this. Okay, and this right here in general, this formula here, gives us the number of combinations of r elements chosen randomly from a set of n elements. Okay, so I'm going to write that down and then we're going to apply it. Okay, so the number of combinations, number of combos, as they say, number of combos, okay, uh, of R elements chosen, of R elements, elements are things, right? In which case it could be a pizza, it could be a prize, it could be anything. We'll talk about that here in a minute. So the number of combinations, combos of R elements, all right, chosen from N elements. So chosen from N elements. I know that's a mouthful. Whenever it comes to mathematical formulas here, especially in the beginning with all variables, there's a lot to take in, all right? But obviously I'm going to apply it with 4 different examples here, and it's not as bad as you think. Okay, so when we say this, we say n choose r. So in red, let's put that down. Just the lingo here, because as you guys know, I always do this in class. We got to be able to write it and do it and also say it. Okay, so we say n choose, okay, r. That's how you say it. And the question is like, how many combinations are there in a certain situation? And so we're going to go over the different mathematics of it. And in the beginning, in the first example, it looks mysterious, it looks abstract. Oh my God, okay, but it's really not that bad. Okay, now before I handle a problem here, I have to talk about what a factorial means. So this symbol, so n factorial here, this is the factorial symbol. So the way we say that is n factorial. And it's actually fairly easy to compute with the aid of a calculator if the numbers get big. And n factorial is equal to n times the one before it, which is n minus 1, times the one before it, which is n minus 2, times dot, 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 okay, times a bunch of terms all the way down to 1. 3 times 2 down to 1. So before I launch into this, let me just do some factorial examples so that you know what I'm talking about here. So let's say, let me just start small. So 4 factorial. So again, this symbol is the explanation point, but you say factorial. Okay, you don't say 4 explanation point. Okay, that's not how to say it mathematically. Okay, so tell the person next to you 4 factorial. Okay. And all it is, it's a product of terms. 4 times 3 times 2 times 1. 4 times 3 is 12, times 2 is 24. And that's all there is to it. Let's do one more for funsies. Okay, let's try 5 factorial. Okay, so that's 5 times 4 times 3 times 2 times 1. And if you think about it here, so let's think about it. 5 times 4 is 20, times 3 is 60. This is times now. Times 2 is 120. So factorials grow really, really fast. Okay, and when the numbers get big, we will use a calculator. But today I'm going to try to keep the numbers small so we can do everything by hand without the aid of a calculator. Okay, so let's go for it here. So let's read it here. So this first example is choosing two prizes from a set of six prizes. So suppose you've won first place in a contest and are allowed to choose two prizes from a table that has six prizes numbered 1 through 6. Notice what it says. How many different combinations of two prizes could you possibly choose? So if you're choosing 2 from 6, we say 6 choose 2. Okay, so I'm going to write that in words. So 6 choose 2. Okay, that's how you say it. And how do you write it? Well, you write it like this. 6, and then you use capital C, 2. 6 choose 2. How do you evaluate it without a calculator? Well, you use your formula here. So we're going to start off with the numerator here with n factorial. And remember, it's always n choose r here. So n is 6 and 2 is r here. And you want to evaluate this formula right here. So 6 choose 2 would be 6 factorial divided by r factorial. Now remember, r is 2. So 2 factorial here times 6 minus 2 factorial. You have to use your formula and then simplify it without a calculator, which, believe it or not, is fairly easy to do. Okay, so what we do is we expand the factorials first. So I'm going to write the word expand here, which simply means write out what it means. Okay, so expand first. So and again, in this video here, guys, and when you're in class, which you are, all right, or if you're at home, it doesn't matter. You pause, play, and rewind it, go at your own speed. So let me just mention that because you may do that right now, okay? Or not right now because we haven't done anything yet. But as we go through this, pause, play, all right, and of course rewind and go at your own speed because it's a video, right? Okay, so now let's focus in on this. Okay, so what does 6 factorial mean? Well, it means 6 times 5 times 4 times 3 times 2 times 1 divided by 2 factorial. So let's handle this part first. Well, 2 factorial is simple. It's 2 times 1. Now, this right here, that 6 minus 2 factorial, well, guess what? That's 4 factorial. This is 4 factorial. And what is that? Well, that's pretty straightforward too. So use dots for multiplication. That's 4 times 3 times 2 times 1. Okay, now you obviously don't have to multiply all these things out. You got to be smart, right? And what you want to do is simplify first. So I'm going to make a little note of that. Simplify first. Because if I tell you guys that you can do this without a calculator, I really mean it. Okay, I do not multiply all these numbers together and then, up top and then do the same thing down below. That's silly. Okay, so what we do know is this. The 4 divided by 4 is 1, right? 3 divided by 3 is 1. 2 divided by 2 is 1. Look at that. We simplify first. And then up top, we only have 30 now. So if you want to multiply and then divide, you can. You go 30 divided by 2, okay, which is 15, and you are done. There's 15 ways you can pick two prizes from 6. Or you can even simplify it a little even further. Watch this. You can go 2 into 6 is 3. 3 times 5, guess what? You still get 15. Okay, so there's 15 ways you can choose two prizes from 6. So let's write out what it means. There's 15 different ways. 15 different ways, all right, to choose. Notice I use the word choose again. Two prizes, all right, from 6. There we go. Now you know how to play a little prize game. If you ever guys go to the Del Mar Fair or somewhere cool, Orange County Fair, and you got a lot of prizes to choose from, and you get to choose more than one, now you can figure out the different ways you can do it, right? You can say, stop, wait a minute. All right, let me figure out the mathematics of this first before I do any choosing. Just kidding. Okay, just messing around. All right, now let's get good at the mathematics. Oh, actually, wait a minute. You know what? Before, slow down, Ainsworth. Let me show you the fast way to do it. Okay, now watch this. I'm going to redo the problem, so just drop your pencils. I said drop them, okay? And let me show you the way Ainsworth would do it here, the quick way. Okay, so I'm going to take the same problem, do it over here, and just watch. You don't have to take notes. 6 factorial divided by 2 factorial times 6 minus 2 factorial, which is just 2 factorial. So what I do, if I was doing this myself here, is that I know what 6 and factorial and 4 factorial means. So what I do is I focus in on these big factorials here, and I expand the 6 factorial up until 4, and then I stop. Now watch why, okay? 6 factorial means 6 times 5 times 4 all the way down to 1, but I'm going to stop there at 4 factorial because I see that in the denominator. I'm looking ahead. And now 2 factorial, that's obviously 2, but then I got this times 4 factorial over here. And the reason why I can stop there at 4 factorial is because I know that anything divided by itself is 1. So these would simplify to 1, and then I get the same thing again. 30 divided by 2 is 15, and then you're done. All right, so this is the slick way. All right, and the most efficient way to handle it, all right, is to stop at the highest factorial, simplify, and then boom, you're done in seconds. And notice I did not use a calculator. Okay, now let's get some practice here. Let's go to the next one, problem number 2. And again, pause, play, rewind. If I went too fast right there in this previous part here, rewind and watch it again. Because the mathematics is actually not that hard, but I may go too fast. Okay, now here's a second problem. We're going to choose 3 students from a class of 12. All right, 12 kids that is, or 12 students. So suppose the scenario goes like this. A teacher is going to choose, we're going to choose 3 students, so let's highlight this. Okay, notice the word choose all the time. We're going to choose 3 students from her class to complete a spelling bee. She wants to figure out all the different unique teams of 3 that can be created from her class of 12 total. All right, so this is the total possible. That's like the total population, for example, and this is your sample size. Okay, what you're choosing, 3. So out of 12, we're going to choose 3. Out of 12, okay, we choose 3. And notice how I say that. So the way you write that is 12 choose 3, where n is 12 and r is 3. Now let me just put the formula right here. So when we deal with combinations here, it's always n factorial up top divided by r factorial times n minus r factorial. So this is your combination formula. Okay, I'm just going to put that off to the side because you may not have it memorized, which you probably don't. Okay, which is okay. All right, so here we go. We're gonna set it up. So we're going to do 12 factorial divided by 3 factorial. Remember, it's always r factorial first times 12 minus 3 factorial. And if you think it's important to write these little factorial symbols, you are correct. Okay, make sure you write them down. All right, now if you want, you can pause and play the video right here. So if you understood what I said on the first example, this first one up here, then you know what? Pause the video right now and give it a shot. In fact, let's do that. Pause the video, go for it, and then press play when you're ready. Go. All right, now let's see if you guys are right. Let's check your work, okay? So I'm going to simplify a little bit first. I got 12 factorial up top, 3 factorial. I'm just going to handle one thing at a time here. Actually, I'll expand that here in a minute. 12 minus 3 is obviously 9. Okay, so here we go. So what do we have up top? Notice that I have a 9 factorial down below. So I'm going to do it the slick way, okay? I'm going to expand the 12 factorial and stop at 9. So 12 times 11 times 10 times 9 factorial and stop. Because look in the denominator, there's a 9 factorial there. Now I do have a 3 factorial, so I'm going to write that first. 3 factorial is 3 times 2 times 1. That's obvious. But 9 factorial, well, I'm not going to expand that because it's going to cancel out with the 9 factorial up top. And if you guys wanted to like expand the 9 factorial and then cancel out all those common factors, go for it, okay? But you know, typically anything divided by itself is 1, and then you simplify a little bit, okay? So what, there's different ways you can do this. So how about 3 into 12 is 4, okay? How about 2 into 10 here? That's 5. And so I have 4 times 11 times 5, and then I'm done. So 4 times 11 times 5, well, that's the same thing as 20 times 11. And that's easier to do, so multiply these two first. 20 times 11, well, that's 2 times 11, which is 22 with a 0 on the end. So notice no calculator there. All right, so there's 220 ways to choose 3 students from a class of 12. So there's 220 ways, all right, to choose, okay? Choose 3 students, all right, from a class of 12. That's what your answer means. There we go. Now let's get some more practice. We're going to do 2 more problems, and I want you to pause and play as we go. Okay, combination problem number 3. Choose 5 menu items from a menu of 9 items. So we're choosing 5 from 9. So suppose, here's the scenario. So suppose a restaurant asks some of its frequent customers to choose, oh, I changed the numbers. Okay, I got to modify this. So to choose 5 menu items, all right? If the menu has not 18, but it's supposed to be 9. Okay, so 9 items here. I forgot to change my numbers here. How many different answers could the customer give? Holy cow. So we're choosing 5 items from 9. Okie dokie. Okay, so let's write down, choose 5 from 9 total. So choose 5 from 9, or you can say 5 choose 9, or excuse me, 9 choose 5. That's how you say it. So 9 choose 5. So from 9 items, we're choosing 5 menu items, okay? So 9 choose 5. 9 choose 5, in quotes. That's how you say it. 9 choose 5. Okay, so here we go. One more time. It's always n factorial divided by r factorial times n minus r factorial. Every single time. So 9 factorial divided by 5 factorial times 9 minus 5 factorial. Okay, at this point, pause the video, work it out, and then press play when you're ready. All right? Okay, let's check your work. So the first thing we do is we simplify the denominator a little bit. We got a 5 factorial times 4 factorial. Okay, obviously 9 minus 5 is 4. So you simplify a little bit. Now you want to expand the top factorial and stop at the largest factorial in the denominator, which happens to be not 4 factorial, it's 5 factorial. Okay, so here what we're going to do is we're going to expand this. So here we go, 9 times 8 times 7 times 6, and I'm going to stop at 5 factorial because I see a 5 factorial down below. Then you cancel out the common factorials. Look at that. Now what do we have? Well, I'm going to look at the numerator. I've got a 9 times 8 times 7 times 6. The 4 factorial is 4 times 3 times 2 times 1. Okay, so I just expanded the 4 factorial right there. So from here to here, okay? Just expand it. Okay, and then you start simplifying like crazy. So I see 3 times 2 in the denominator, and 3 times 2 is 6. So these two, 6 divided by 6 is usually 1. Okay, and then I see 4 and 8. So 4 divides into 8 twice. And then what do you have? So let's write out all the remaining numbers. 9 times 2 times 7. And then, what is that? Well, that's 18. Oops. That's 18 times 7. So what's that? Let me see, 70 and 56. Sounds like 126 to me. So there's 160 ways the customer can answer the person at the restaurant here. There are 160 different choices. Okay, different choices. Okay, if you choose 5 items from 9 total. Okay, if you're choosing 5 items from a total of 9. Okay, there we go, and that's combination problem number 3. All right, let's just do one more here, and then when I get back in class here, we'll do some more work and we'll apply it in the workbook. All right, when we get there. All right, then let's go through and let's talk about the famous handshake problem. All right, so in a group of 10 people, how many different handshakes are possible? Holy cow. So when you handshake, when you give handshakes, you're only dealing with 2 people at a time. So what this problem is, it's really asking you when you're trying to figure out the number of handshakes. You have 10 people, but you're choosing only 2 at a time to handshake. So again, we're handshaking. We're only, you only shake hand with one person at a time. That means 2 at a time. Okay? Meaning there's 2 people given a handshake simultaneously. So what we need to figure out is 10 choose 2. All right? Because 2 people give a handshake simultaneously. Right? So what in the world is 10 choose 2? So let's figure that out. So one more time, your formula goes n factorial divided by r factorial times n minus r factorial when it comes to combinations. All right, so let's write it out. So we're going to have 10 factorial up top divided by 2 factorial times 10 minus 2 factorial. Okay, so at this point, stop the video, work it out, and let's see what happens. Okay, so I'm going to assume that you guys work this out. So the first thing we do is we simplify the denominator a little bit. So I have a 2 factorial there. And then we have 10 minus 2. Well, guess what? That's 8. So I have to multiply it by 8 factorial. All right, 10 minus 2 is 8. So I got a big factorial in the denominator, and that's kind of nice because then it's easy to do mentally. Okay, so we want to expand the top up until the factorial, the biggest factorial in the bottom, which happens to be 8 factorial. That's the biggest one. So I'm going to go 10 times 9 times 8 factorial, and I'm going to stop. And then I've got 2 factorial, which is just 2 times 1 times this 8 factorial. So all I did was rewrite 2 factorial as 2 times 1. That's the only thing I did. All right, and then I've got these factorials here. I got 8 factorial divided by 8 factorial, and that's obviously 1 because they're the same number, right? So anything divided by itself is 1. And then what do I have left over? Well, I have 10 times 9 divided by 2, but 2 divides into 10 5 times. 5 times 9 is 45, and I'm done. All right, and there's 45 handshakes, different handshakes that are made. So 45 handshakes with 10 people. Okay, so if you have 10 people and you want to count up the number of handshakes, there's going to be 45. All right, and there we go. That's the mathematics of combinations right there. And now what you guys need to do is you need to try it. So there's a few more in the next page. All right, so you try these, and then you go to the next page and try a few more, and you check your answers with each other. And then when I get back in the class, we will go over some more application of the combinations. All right, so this is Mr. Ainsworth here. Hopefully that helped you out. And again, do your work, finish your examples, check with each other, and I'll see you back in class. All right, take care, guys. Bye-bye.